What's up guys? Welcome back to my YouTube channel. Today you're going to learn about wave interference and phases. Please watch the following video. We love and miss you guys. Best of luck.
Welcome everyone, this is 11.6 wave interference and phases. So to start this lesson, what I'd like you to do is look up FET wave interference, click the first link and then hit play. The first part of this lesson in class would have been you going through part 1 of this, as well as part 2 and waves of barriers. There are some instructions for you to follow. You can pause this video now, go ahead and get started on the simulation, and when you are done, you can come back to this. Now you're coming back and you're ready to take some notes. And to continue our notes, we are going to start on the same notes page from last week. And that notes page is going to now help us define phases. Okay, so when we talk about phases, we're going to talk about essentially wave parts. Waves can be in or out of phase with each other, and all that means is if they are kind of lining up in a way that we would expect. So first we're going to write down some definitions, and then we will come back together and actually apply what this means in the worksheet that you picked up on last week as well. So phase just means any part of a wave, compared to another part. Okay, when we say that waves are in phase, what that means is when two or more waves have the same phase. Which means their crests and troughs line up. For a very generic example of this, taking a look at these two wave structures, so let's say that we have A and we have point B here. We are lining up because we see that the crest here is lining up for both. But point C, which would be down here, would not be in phase. So here, A and B are in phase. Whereas C is not in phase with any of these points because it is not the same location as A and B. And when we are out of phase, that means that two or more waves do not have the same phase. So let me actually show you that with two different examples now. So let's say that I have wave A, or point A, and second point with wave B. You can tell here that wave A is at a crest and wave B has a trough. And so there's no lining up here. These are not in phase with each other. Okay, so now let's practice this on your worksheet. I'm going to do the first couple with you, and then I want you to pause and try the rest of them on your own. So we've got a whole bunch of waves here. You can see that there's one wave that's a solid line and one wave that's a dotted line. And let's go through it together and kind of figure out if these moments are in phase or out of phase. Okay, so at 0 seconds, at 0 seconds, it appears that on the solid line wave we're at a node. On the dotted line wave, we're at a crest. So these to me would be out of phase. They do not line up. At 0.5 seconds, which is right here, they're both at nodes, which might originally look like they should be in phase, but a reminder that this is at a node moving up, this is at a node moving down. Because they're moving in different directions, even though they are both at nodes, this is still considered to be out of phase. Okay, go ahead and pause the video now and come back when you have finished 3 through 8. Okay, so we have, we can take a look at the rest of these, right? So at 1 second, which is right here, this is at a node, this is at a trough, that is out of phase. At 1.5 seconds, they're both at nodes and both heading up, that is in phase. At 2 seconds, one is at a crest, one is at a node that is out of phase. At 2.5 seconds, they're both at nodes, but one's heading up and one's heading down, so that is out of phase. At 3 seconds, one is at a node and one is at a trough that is out of phase. And at 3.5 seconds, they're both at nodes and they're both heading up, so that looks like they're in phase to me. Okay, next example. Which of the following are in phase with each other? All right, I'm going to pause the video now. I'm going to ask you to pause again. Just take a look and see if you can figure out what the correct answer is. Okay, so there are actually two correct answers in this question. Correct answer number one, that I think is more obvious, is B and C, because those are both easily identified crests. But the other places that are technically in phase with each other are also A and E, because at point A, we're about to head up, and at point E, even though it's not shown, we are also about to head up. Those are also technically in phase, but B and C, I would say, is the more correct or more easily identifiable answer. Okay, that's it for today from me. Actually, there's one more thing I want to write down before that. I'm lying to you. Let's define diffraction real quick. Now, diffraction is something that you're going to see or you saw in your lab, and I want to just write down a formal definition. Diffraction is the bending, spreading, and interference of waves when they pass through an obstacle or narrow opening. And so we saw a little bit of diffraction in the lab. We'll talk about it more. But essentially what I want you to think about is the idea of you yelling through a doorway, for example. And when you yell through a doorway, you're able to be heard on either side of the doorway. That's a good example of diffraction. Because as the sound waves pass through a small area, let's say that we're heading this way, they will spread out as they go through that slot. So they go through and they spread out. That's diffraction. All right, guys, you are responsible for finishing out the rest of this worksheet, coming and prepared for tomorrow. And yeah, best of luck finishing everything up.